work in my PhD, and is not at all what I was working on here at Google on the Magenta team on brain research, but is related. You'll start to see how this is all related. I've been improvising for longer than I've been doing science. So this is me, like a fresh-faced youngster in 2007 with the artistic director of my theater company. Back then, this is me on stage at Rapid Fire Theater, and this is Jacob Bannigan, who gave me some really good advice early on in my time at the theater company. I'm going to focus on the people because I think the people are really what make this story interesting. So the characters in this story are what make it interesting. So this is Jacob, and he told me that a good improviser looks good on stage, but the great improvisers make everyone else look good. So that's the foundational principle of this entire work, is that someone can get on stage and improvise, and that's great. They can work with anyone else, and the best improvisers can make literally anyone look great. It's not about them, it's not about the audience, it's not about the show, it's about that moment where two people work together to make each other look good, and the audience enjoys watching that. So I took that principle and turned it into a show called 15 Minutes of Fame, which I did over the course of 6 months. This is me on stage with Raj, and he had never been on stage before, never done any kind of speech, never been in front of an audience, and he's acting pretty hard here and doing a really good job. The audience absolutely loved him, and this show kind of showed me that I could bring someone up from the audience and do a show with them. I was getting better at making them look good, and they were starting to feel more and more comfortable, a different person every time. And it was enjoyable, but it got to a point where I learned a few tricks, and you start to learn what a naive person wants when they start doing improvisation, and then you can sort of make them look good regardless of how they are. As long as they're comfortable and saying yes and following some of the basic principles of improv. Everyone knows the 3 rules of improv, right? Like, say yes, don't ask questions, and be positive? Yeah? Yeah? There you go. Any questions about that? No? Yeah, yes, I do have questions. Immediately falls apart. So as long as someone follows those like general rules, you can like get an improv scene out of it. So I thought, okay, I'm a computing science student, so can I make an improv out of an AI, and can I make that AI look good on stage? I know that the current state of the art is not great. We have dialogue systems that are closed domain that help you book tables at restaurants, as we talked about over lunch yesterday, that help you book a flight. But how do you make an AI system make it look good on stage? How do you make it appear as if it's engaged in the show? And how do you, it's an exercise in justification. How do you make this thing look good, knowing that it's going to be random and naive? So I was talking this over during a show with Mark, Mir, and Adam Megiddo. This is Adam Megiddo, who's sort of my improv mentor. He's in the UK. He's in London with Piotr. He's part of a group called Showstoppers, which is the first improvised show that's ever won what in London they call Dora. Is that right? Which is like the Tony Award. It's like a Tony Award for a Broadway like show on the West End that is improvised music. So he's great, this awesome dude. I was telling him about this AI idea, and he said, the first time is going to be the worst time, but get that over with because the science is going to get better every year. And he had no idea. It's not like he's an AI scientist. He just knows that's how science progresses. And this was really like permission in my head to do a bad show, get up on stage with an AI and do it, and then make it better and start iterating on it. So he said version 1. In not so many words, he said version 1's the most important. Just start iterating on it. So I started digging in like any good researcher would do. You can see here, this is 2 robot actors posing in costume. This is work by Brian McGarko, which was sort of, you know, once you start doing a naive keyword search on Google Scholar, you find stuff like this, using drama to create believable agents. This is work from like 17 years ago, but it was all hard-coded flow charts. So if I say this, you say this. If I do this, you say this. If I move this way, then you move this way. These flow charts are interesting, but the audience starts to pick up on what the patterns are very quickly. So I was talking about these flow charts and the and the like generative nature of a system that I wanted to build. With Michael Littman, who's an AI researcher in the States, and he told me it doesn't take a genius to do your taxes. That's not true. This is him in a commercial. He actually told me, embrace your passions, which is like advice to be like, whatever you're working on in your PhD, make this it. Like, follow what you want to be doing, because then you will actually have the like gusto to continue doing it. So I was working on some robotic stuff. I'm not a roboticist. I have a tough time working with robotics because it's nitty-gritty. It's a lot of details, and I'm just not passionate about robots as much as I'm passionate about improv and the art and the creativity that comes from performance. And he kind of gave me the permission to leave that robot work and move into this more creative side. He introduced me to this man, Tom Seguros. Tom did a show with a robot called Judy, or What It's Like to Be a Robot, live in front of audiences, and it was well received. And I had a lot of good dialogues with Tom. Tom had programmed this, which is Judy, which is kind of like a Kuka arm, but with like a funny face put on, little eyes, and different, things that make it more human-like, things that change its appearance. It was it was good. There's also other robot performances. I would be remiss if I didn't mention Carnegie Mellon has a robot that they do stage productions with. You can see in the background here, there's like a pilot that's full-on piloting the robot on stage. Tom in the slide before had buttons that were hidden around the stage that he could press to make the robot on stage do certain things. One sec, there we go. And there. This is Geminoid F, another robot. This is the robot doing a show in Japan. It's like a humanoid-like robot. In Japan, this show was like very well received by reviewers because it's so human-like. It really like pulls the attention. But it was her performance, Brierly Long, that really made it captivating and interesting because she had such emotion, she brought such emotion to the role that all the show was this robot saying goodbye, and it was her acting against this robot, having to accept its goodbye. That robot was made by Hiroshi Ishiguro, which is this guy, a Japanese roboticist, and if he looks weird there, it's because that's not actually him. That's him. He makes robots that look like him and then film him taking conversations with the robots because he's so focused on this like idea, this disgusting uncanny valley, which is a theory that you may have heard in the robotics world, but it also exists in sort of the communication world. And it's the idea that as things become more human-like, we kind of find them disgusting. So this is like how much we kind of are familiar with them, how much we enjoy them, and there's this weird, sick, uncanny valley here where corpses and zombies are, and where I've heard it argued that some dialogue systems are. Yeah. Yeah. In the Hiroshi Ishiguro, the uncanny part is that it's when it's moving and talking that you see this like form that looks human-ish but isn't exactly human. We are imbuing something with human-like qualities, and they're so similar to a human that we are not okay with that. Like, I think it has to change for us to know, because you may not even know that that's a human or who the human is there. There's nothing really disgusting about that, or obscene, like as Weizenbaum would say, Joseph Weizenbaum. But once it starts to move or do something, then it might be disgusting. I don't personally find this disgusting. I think we all have different uncanny valleys, what we would find okay and not okay. But does that maybe, yeah. Of this, he doesn't make them move. Yeah, he just builds them by taking out his hair and then putting his hair into these things. And like, so like, is that gross? I don't know. If you know that that's what the hair on that head is, it's kind of weird. But yeah, the movement happens from someone else. Someone else is making the movement happen. So this is me. This is the first time that I did the show, April 8th, 2016, and I did the show at Rapid Fire Theater. They were nice enough to let me do a performance of it in front of an audience. It was very experimental, and it was me and this embodiment, a big projection on a screen. It was just a face, and the face moved kind of when sound came out. And I named this face Pygmalion after the story of Pygmalion. Does anyone know the story of Pygmalion? Yeah, I see some nods. So the idea is this person tried to create a beautiful counterpart and was damned for all eternity because they had tried to do so. Yeah? Yes? I'm looking at you. Yeah? Yeah, you were nodding about Pygmalion. All right. Okay, right on. So I felt like I would label this Pygmalion and move on. As I started to program this, Pygmalion, Piggy for short, had a lot of hard-coded rules. The hard-coded rules are a lot like Eliza's hard-coded rules. So this was the first chatbot, Joseph Weizenbaum's first chatbot at MIT. In 1966, was set up on a computer, and then he got people to interact with it. There's a famous story that he got some naive professor to start chatting with it, but then rather than using the dialogue system, another human was the back end, and they sort of played a Wizard of Oz trick on this naive professor. That is maybe obscene. That is maybe the uncanny valley that we're afraid of in these chatbots. Something to think about there. But needless to say, the system here works by sort of taking a keyword. Like on the right-hand side, you can see the keyword, and then based on the keyword, it just has a response. So you say something like, "You are always listening to me and never talking," and then it would say a canned response like, "What makes you think I am?" Question mark. Insert response there. Hard-coded rules, which are good and work sometimes, but sometimes we need more than hard-coded rules. So, needless to say, any good chat agent has speech recognition, a dialogue system, speech synthesis. Piggy was built on Apple speech recognition and speech synthesis. It used Google to do the speech-to-text, and it used two different dialogue systems, Pandora bots and Chatterbots. One of them is like hard-coded rules, and one of them is kind of learning to just say what you said because we enjoy that as humans. That's the naive tech. I trained the dialogue corpus of it with like a simple web interface, Chat with Piggy, it was called, and I released it to all my improv friends, and everyone knows what happens once you release a training system online. I had a bunch of improv friends just teach it to say, "Eat my shit," and stuff like that. So it was completely a useless data set. So that was unfortunate, but it led me to the Cornell Movie Dialogue Database, which has a bunch of conversational pairs and is good dialogue between characters. It's well tagged, it's very clean, and is a good place to start if you're building conversational agents. Shortly after I did the show, I wrote it up as a post on my blog, and then I got an email from this guy from DeepMind, just sitting and watching us kind of nicely. Can you hear us?
Yes, no. It's okay. I got everything that you said.
Perfect. So that's why we have a little bit of an echo. But needless to say, after that show on May 3rd, I got an email from this guy that said, "I'm working on training neural networks to do an improv show with me in artificial intelligence. I would love to chat with you about it." This was the start of our friendship and our collaboration on this system. I'll take you off. Can you turn down your speakers a little bit over there?
Oh, yeah, sure, I can.
Thank you.
Yeah.
Cool. So this is Piotr and the Easy Robot, which is what I was trying to describe to someone who was thinking about what robot to use. Now, can I advance this slide still? No. Okay, well, we're frozen. It was good while it lasted. This was a pretty good talk, I'd say, so far. Unfortunately, it's over.
Oh,
it's okay. We're still connected to Piotr.
hello. Do you want me to draw you the schema?
Yeah, no. Honestly, all we can see, maybe our story ends here.
Oh.
Disconnect what?
Disconnect me?
Yeah, can you disconnect us?
I can.
Thank you. Bye.
Goodbye.
Hey, it worked. Thanks. Great, now we can talk about him without him being here. Okay. Will he reconnect? Say again? Nice. This is the best part about being at Google. You can just be like, hey, how do I do this Google thing? Is that right? Like, cool. Hey, we're back.
Great.
Okay, cool. So let me do it like this. Does that work? Nope. Okay, I'm going to try this again.
Shouldn't say that, I guess.
It won't advance the slide now? Oh, there we go. I see. It's because there's hard transitions. Okay, one sec. I know what we'll do is disconnect the video here.
Okay.
Sorry. There we go.
Yep.
There. So this is Alex. I'll give you some details on the architecture of Alex. Sorry about that. So Alex is version 2 of Piggy. Piggy had limitations because a lot of it was hard-coded, and it had some restrictions because it was connected services like Pandora bots and Chatterbots and Google Speech API. So we needed to build something that was like deployable and standalone. So Alex is a recurrent neural net, which is used for text generation. It has a dialogue system, which is used for the turn taking. So I speak, then you speak. That's a hard problem to solve when you're doing improv on stage, knowing when to start and stop talking. It has a speech recognition system, which is plugged into the Apple speech recognition. It has text-to-speech. It uses the Apple text-to-speech, and it all runs off a MacBook. It has a user interface, so it has a visualization that I'll show you at the end of this when we do a little demo. And then it has a LAN server, so that this says LAN server, so that I can, so that we could do AI to AI communication. So if I want to run a robot in Portland, Oregon, say, and Piotr wants to run one in London, then we can make them do a show across the internet to 2 different audiences, which is something that we did. Then it also has a remote control, so it has cameras, peripheral cameras, that it can use as both sensors and outputs to screens. And it can have physical avatars. So we've used different robots to have stage embodiments. All the reasons that you wouldn't want to do a play or an improv with babies or dogs on stage are kind of the same reasons you wouldn't want to do improv with robots on stage, because then it becomes maybe more about that. If you want more technical details, so it's trained on open subtitles, which is over 100,000 movies. It's less clean than the Cornell movie database, but we have over 1,000 cleaning rules, like hard-coded cleaning rules, which takes a lot of time to sort of build candidate responses and generations based on those cleaning rules. It's built on Torch RNN, so it's all built in Torch and Lua, a recurrent neural network with long short-term memory. It uses a topic model that is computed in real time to try to figure out the topic of the current improvisation, and then it biases the generation word by word on that topic. So this is something that you would do in improv. Say, when you get a suggestion from the audience, then you may start to bias what you're saying towards that topic. It is trained with supervised learning strictly right now, but we're thinking about ways to incorporate some kind of reward signal into the training. So I'd be curious if you had some ideas on how to do that or what signals to include. We may want something like self-coherence, or how well the audience reacts, or how similar it is to the other improviser on stage. These would all be like reasonable reward signals. Then we could use those to update this deep network and bias the responses in a different way. So you may say, like, can Alex stay on topic? And it can stay on topic as good as it can bias towards a certain topic vector. So we've taken 64 topics from all the 100,000 movies that we've chowed down with this data cruncher. And the topics are like this, which is kind of spacey, or this, which is kind of Japanese words. And those topics, if we can successfully get into one of those topic spaces in the manifold of topics, then we can bias towards that in the generation. What we're trying to do is compute that topic in real time from the current conversation, the context of the current conversation, and then use that information to push towards one of these topics. So we're hoping that it helps it to stay on topic. Did you have a question?
Yeah, so this randomly topic from one is word and
yeah. These are the limitations of statistical language models, is that sometimes you end up with stuff like Angelina sitting in a Japanese words topic because it was based on word frequencies, so words that occur together. And I don't know exactly why that happened. Explainability of these deep networks is kind of difficult, but I could assume that it kind of looks like a Japanese word and how it uses A's and I's. Maybe Angelina Jolie had something to do with it. Hard to say. So this is me and Piotr performing in a transatlantic improv. So I'm in Portland, he's in London. He's performing with the robot. I'm on the screen behind him. This was March 31st, just before I came to Google. We've done a few different shows, Albert and Alex, Miles and Piggy, Binary 2, and Long Distance Relationships, which are just scenes between two humans, which is something that people really want once they watch this human and AI improv for a little while.
Right.
If you want to find out more, you can check out HumanMachine.live. We're in the Camden and Edinburgh Fringe Festivals later this summer, and we'll perform more shows, and then this will continue as some of my scientific research. One of the cool and exciting next steps is the idea that we may be able to bias towards a certain plot. So a lot of how Alex works is based on the context with which we give it. So in an improv, you want a solid context. So Plotto is a book written in 1928 by this guy named William Wallace Cook, and it's an algorithm to define arbitrary plots. He's like written this encyclopedia of different plot points. So now we can generate plots alongside the dialogue and then hope that the audience can then make those little connections so that when the bot says something naive, if we can tie it into the context that we've also defined, then the audience can make the connection a little more subliminally than the robot having to make the exact right dialogue suggestion. So Plotto kind of works like this. You might give it a plot point like, A, the male protagonist falls in love with B, the female protagonist, the criminal he has arrested and is returning to the scene of her crime for trial and punishment. And then the next plot point might be something like, if you follow this 53 tag, which is what he had set out, this key value, A loves B, B dies, A becomes demented through grief. And then we have like, the full story is in the top right. Those are like randomly chosen A, B, C plot points, and then we're fleshing out like each beat of the story here. So we can imagine generating a full story in plot points alongside a dialogue that is happening, because seldom in an improv are you actually talking about what's physically happening. You're kind of talking like you would normally, which is in double entendre and subtext. So you're not necessarily talking exactly about how chopping carrots is your favorite thing to do all the time. Needless to say, plot is one of the exciting next avenues of Alex. So that's the end of the presentation.